we should actually be calling the industry anaerobic digestion, which is the process we're actually referring to when we talk about biogas, but obviously it's not the most easily digestible term. AD, as we call it, is the same process that we all use to digest our food. So some of us will be digesting our lunch at the moment. But the industry is simply doing the same thing in a tank. So effectively, all of those wastes, which were once plants that had absorbed the sun's energy. So what all those millions of microbes are doing in a tank or in our stomachs is breaking down that organic material and extracting what was once the sun's rays in the form of energy, in the form of biogas, and leaving everything else behind. The biogas itself is essentially about 60% methane, which is the same molecular constituency as natural gas, and 40% bio-CO2. And the everything else is literally everything else. So all that organic material that went into it, including all the nutrients, can simply be comes out at the other end and turned into a biofertilizer to be returned to soil and to go back into the food production circular economy. So I think Jose already highlighted the fact that when we're talking about biogas, we're talking about methane, which is the same exactly the same molecular structure as natural gas, means that we can simply put that biomethane into the existing infrastructure, replacing the fossil gas and thus preventing it into the atmosphere. It's technology that is widely used today, can be rapidly scaled up, and is the most cost-effective way of decarbonising this decade. Hydrogen is coming, but it is not coming this decade.